Equations are like secret codes that unlock the mysteries of the universe. They are powerful tools used in mathematics, physics, engineering, and many other fields. By understanding equations, we can describe relationships between different quantities and solve for unknown values. Think of an equation as a balance scale. Both sides of the equation must always be equal, just like the two sides of a scale need to be balanced. When we solve an equation, our goal is to find the value of the unknown variable that makes the equation true. In this essay, we'll embark on a journey to explore the world of equations. We'll start by unraveling the secrets of two-step equations, and then move on to the slightly more challenging three-step equations. So fasten your seatbelts and get ready to explore the fascinating world of equations. Two-step equations are like puzzles that require two steps to solve. They involve two operations, such as addition, subtraction, multiplication, or division. These equations can be used to represent real-world situations, such as calculating distances, figuring out costs, or determining speeds. Let's look at a simple example of a two-step equation. 2x plus 3 equals 9. In this equation, x is our unknown variable. Our mission is to find the value of x that makes this equation true. To do this, we need to isolate x on one side of the equation. To solve a two-step equation, we need to follow a specific order of operations, just like we do in many other areas of life. Much like following a recipe. Each step must be done in the correct order to achieve the desired result. The key is to remember that whatever we do to one side of the equation, we must also do to the other side to maintain balance. This is similar to balancing a scale. If you add or remove weight from one side, you must do the same to the other side to keep it balanced. Step 1. Isolate the variable term. The first step is to get the term with the variable by itself on one side of the equation. This means we need to move any constants to the other side. In our example, 2x plus 3 equals 9, we need to get rid of the 3 on the left side. This is done by performing the opposite operation. To do this, we can subtract 3 from both sides of the equation. 2x plus 3 minus 3 equals 9 minus 3. This step ensures that the equation remains balanced. This simplifies to 2x equals 6. Now we have an equation where the variable term is isolated on one side. Step 2. Isolate the variable. Now we need to isolate x completely. This means we need to get x by itself. Since x is being multiplied by 2, we can divide both sides of the equation by 2x divided by 2 equals 6 divided by 2. This step is crucial to solving for x. This gives us x equals 3. We have now found the value of x that satisfies the equation. We have successfully solved for x. This process of isolating the variable term and then isolating the variable itself is the foundation of solving two-step equations. With practice, it becomes second nature. Let's try another example to solidify our understanding. Suppose we have the equation 4y minus 5 equals 11. Step 1. Isolate the variable term. Add 5 to both sides. 4y minus 5 plus 5 equals 11 plus 5. This simplifies to 4y equals 16. Step 2. Isolate the variable. Divide both sides by 4. 4y divided by 4 equals 16 divided by 4. Therefore, y equals 4. We have found the value of y that satisfies the equation. Section 5. Three-step equations, taking it up a notch. Three-step equations, as the name suggests, involve 3 steps to solve. They are like slightly more complex puzzles that require us to apply our knowledge of solving two-step equations and introduce one more operation. A typical three-step equation might look like this. 3z plus 2 equals 5z minus 4. In this equation, we have z on both sides. Our goal remains the same, to find the value of z that makes the equation true. Section 6. Unraveling the mystery-solving three-step equations. In this section, we will break down the process of solving equations that require 3 distinct steps, making it easier to understand and apply. Solving three-step equations requires us to follow a similar process as with two-step equations, with an additional step to combine like terms. This extra step ensures that all similar terms are grouped together, simplifying the equation. Step 1. Combine like terms. This is crucial because it reduces the complexity of the equation, making it easier to solve. If there are like terms on opposite sides of the equation, we need to combine them. This means moving terms from one side to the other, ensuring that all similar terms are on the same side. In our example, we have 3z on the left side and 5z on the right side. This means we need to move the terms involving z to one side. To combine them, we can subtract 3z from both sides. 3z plus 2 minus 3z equals 5z minus 4 minus 3z. This step helps in reducing the equation to a simpler form. This simplifies to 2 equals 2z minus 4. Now the equation is much simpler and easier to handle. Step 2, isolate the variable term. This step focuses on getting the variable term by itself on one side of the equation. Now we need to isolate the term with z. This involves moving other terms to the opposite side of the equation. Add 4 to both sides. 2 plus 4 equals 2z minus 4 plus 4. This step helps in eliminating the constant term on the side with the variable. This gives us 6 equals 2z. Now the equation is even simpler with the variable term isolated. Step 3, isolate the variable. This final step involves solving for the variable by performing the necessary arithmetic operations. Finally, divide both sides by 2 to isolate z6 divided by 2 equals 2z divided by 2. Therefore, z equals 3. This step ensures that we have the value of the variable. We have successfully solved for z. By following these 3 steps, combining like terms, isolating the variable term, and solving for the variable, we can solve any 3-step equation with confidence. Section 7. Example 3-step equation in action. In this section we will break down a complex equation into manageable steps to find the solution. Let's look at another example to reinforce our understanding. This will help us see how to apply the 3-step method in a practical scenario. Consider the equation. 2 times the quantity of x plus 1 equals 4x minus 6. Step 1. Distribute. This is the first step where we simplify the equation by removing the parentheses. Distribute the 2 on the left side. 2x plus 2 equals 4x minus 6. By distributing, we make the equation easier to work with. Step 2. Combine like terms. This step involves simplifying the equation further by combining similar terms on both sides. Subtract 2x from both sides. 2x plus 2 minus 2x equals 4x minus 6 minus 2x. This helps in reducing the equation to a simpler form. This simplifies to 2 equals 2x minus 6. Now the equation is more straightforward and easier to solve. Step 3. Isolate the variable term. This step is crucial as it helps us to focus on the variable we need to solve for. Add 6 to both sides. 2 plus 6 equals 2x minus 6 plus 6. By doing this, we move the constant term to the other side. This gives us 8 equals 2x. Now we have an even simpler equation to work with. Step 4. Isolate the variable. This final step involves solving for the variable by performing the necessary arithmetic operations. Divide both sides by 2. 8 divided by 2 equals 2x divided by 2. Therefore, x equals 4. By dividing, we isolate the variable and find its value. We have found the value of x that satisfies the equation. This example demonstrates how breaking down a problem into smaller steps can make it easier to solve. Practice these steps to master solving 3-step equations. Section 8. Practice makes perfect. Mastering the art of solving equations, like any skill, requires practice. The more you practice, the more comfortable and confident you'll become. Start with simple equations and gradually work your way up to more challenging ones. Remember, it's okay to make mistakes along the way. Mistakes are valuable learning opportunities. The key is to learn from them and keep practicing. Section 9. Equations in the real world. Equations are not just abstract mathematical concepts, they have real-world applications in various fields. Engineers use equations to design bridges and buildings. Scientists use equations to model physical phenomena. Economists use equations to analyze financial markets. Understanding equations empowers us to make sense of the world around us and solve practical problems. Section 10. The power of equations. Equations are powerful tools that allow us to express complex relationships in a concise and elegant way. They provide a framework for logical reasoning and problem solving. By mastering the language of equations, we unlock a world of possibilities and gain a deeper understanding of the universe and its intricate workings. Section 11. Conclusion. Embracing the language of mathematics. As we conclude our journey into the world of equations, remember that mathematics is not about memorizing formulas, but about understanding concepts and applying them to solve problems. Embrace the beauty and power of equations. With practice and perseverance, you can master this essential mathematical language and unlock a universe of knowledge and possibilities.